Alright, in this study we're looking at HVAC systems. The title of this study is called Selection and Performance Assessment of Phase Change Materials for Heating, Ventilation, and Air Conditioning Applications. Phase change materials are useful for HVAC systems because they're able to store a lot of energy in between their phase changes. In this study, they analyzed the phase change materials, in particular thermal absorption capabilities for maintaining comfortable air conditions. In this study, we're looking at between 17 degrees Celsius and 25 degrees Celsius. When comparing these materials, they use Pareto optimal solutions to determine which of the materials is best for the application. And that involves using figure of merits. They want to maximize the values of the figure of merits, and that will determine which is the best material for the application. In this case, we're looking at heat transfer per unit volume, and we're also looking at thermal diffusivity. If we look at the formulas, both of them use density in their equations. But one of them is in the denominator, meaning that they're inversely proportional to each other. As one value increases, the other one will decrease. In the study, they look at heat transfer versus thermal diffusivity to determine which makes for a better phase change material. Ideally, we would want to maximize both, but because they're inversely proportional, we have to look at another criteria and see which is more valuable, and they do that by comparing entropy values. By comparing entropy values, the figure of merits are actually weighted the same because of how little difference there are between each other, and because of that, we're going to have to try and find a trade-off and maximize both as much as possible. Another criteria that they use is temperature regulation versus time. This is a simulation they ran of each material in an HVAC system. It's placed in a four-wall room. Here they measure how well each material is able to regulate the temperature at around the desired 25 degrees Celsius, and how quickly they're able to reach that temperature and maintain it over a long period of time. In summary, the most effective phase change material will have a trade-off between the heat transfer rate and the thermal inertia. And the best material is also going to be able to quickly reach the desired temperature and maintain it over a long period of time. They were able to come to the conclusion that Rubitherm GmbH specification 24E is the best material for this temperature range of 17 to 25 degrees Celsius. All right.